All right. Good afternoon, guys. So,
Good afternoon.
last class we have seen this subnetting. So I gave you some task. So did you guys go and watch the videos once again? Yeah. Now is it clear? Okay. What is the first problem? Dot 100.25/30. So what is the network ID and broadcast ID? 24 and 24 and 27. How is it? So here two bits are there for host. So 2 to the power 2 is 4. So 4 I'm going to divide it by 25. Correct? So 24, one reminder. So minus 1, 24. So plus 3 I'm going to add. So 24 is the network ID and 27 is the broadcast ID. How many of you got the right answer? Everyone? Very good. Okay. Next question. 37/28. So 28 means block size is 16. So 16 divided by 37. So 32. 5 reminder. So 32 will be the network ID. Correct? So plus 15 I'm going to add. 47 will become broadcast ID. How many of you got it right? Okay, very good. Next problem. 66/27. So 32 block size because 5 bits are there for host. So 32, 66. So 2 times 64. So 2. So 64 is the network ID plus 30. 1 I have to add. 95 is the broadcast ID. Done. Okay. And then 17/29. So 3 bits are there for host. So it is 8. So 8 divided by 17 is 8 divided by 17. So 16 is the network ID plus 8 I have to add. 23 will become broadcast ID. Okay. And then 99/26, that is what? 64 is the block size. So 99 divided by 64. So 1 times 64. Correct. So 35. So I'm going to minus this. Then 64 will become network ID. So I have to add plus 63. 7, 1. 127 will become broadcast ID. Correct. Okay. And then 99/25. So 128 is not divisible by 99. So 0 will become network ID. 127 will become broadcast ID. Okay. Is it clear now?
Yes.
Every slash from 25 to 30 I've given. You're able to solve the problem and you got the answers. Correct? Okay. Online guys, any doubt, any problem? I didn't understand. You want me to explain again which one? Which problem? Everything wrong in your broadcast ID. What was your answer for first one? 29 you got. Okay. Next one. 52. 53 you got. Oh, you got 53. Bring your note copy. This one is the first one, right?
Second. First one is please.
This one first.
Yeah.
Okay. So you got the block size first.
Yeah. Block size.
Where is the block size? 30. Oh, you got block size 4. Okay, that is fine. Now you're going to divisible by 25. 24 you got. 1 you got. 24. Okay, you got.
Okay.
So you're going to add this one, right? Block size you're going to add here.
Okay.
You already got 1 IP. 24 you already got. Correct? So plus 3 you have to add.
Okay.
Because in one network, how many IPs is going to be set is based on your block size. So in one network, 4 IPs. Already we found the network ID. So another 3 IPs I have to add. So 27.
Yeah.
How did you add 29 here?
20.
You added one more. 4 plus 1 you added.
Yeah.
You should minus 1.
Okay.
Instead of minusing, you add 1. That's why you got 29. So if you add minus 1 more plus 3, if you add 27, you will get. Here, 16. So you got the network ID as 32. That is fine. So 32 plus 15 you have to add.
Mhm.
So 7, 4.
Yeah.
Okay. Whatever the block size is, minus 1 and add. Why you're minusing? Because already you found the network ID. Every network ID is right. You understood the concept. But adding problem, you made it little confusing. So block size, you have to minus 1 and add it. Okay. There you go. What about online, guys? You want me to explain any problem once again, or is everything clear? Huh? You didn't
Identifying boxes.
identify the?
Box.
You want me to explain? Okay. So first problem is 25 slash 30. Correct. 30 means what? 25, 26, 27, 28, 29, 30. So 6 bits are on. Correct. 1, 2, 3, 4, 5, 6. 2 bits are off. So off bits, how many? 2. So 2 to the power of 2 is 4. If it's 25, so 1 bit is on. Correct. Other bits are off. So how many bits are off? 7. So 2 to the power of 7 is 128. If it's 28, 1, 2, 3, 4. 4 bits on, 4 bits off. Correct. So you have to multiply the 4 bits. So 2 to the power of 4 is 16. So whatever the bits are off, you're going to 2 to the power of that number, and then you will get the block size. Okay. Did you watch the video again yesterday? No. You watched? Don't do that. That's why you get confused. Especially subnetting, don't watch other videos there because there are, I think, 12 or 13 ways you can do subnetting. That will be confusing for any person. Subnetting, please don't go with other videos. Even I suggest you first, if I'm taking any topic, you see my class, again go through the recording and then you do your homework. You see multiple YouTube videos, that doesn't matter. But initially don't go with other videos, you will get confused. Because they're not going to explain you from basic. Even though they explain from basic, they will do a different method. You will get totally confused. Okay, so this division method, the way I'm explaining you the block size is the easiest. Okay, so go through the recording completely. If you don't understand, come to me. Still you don't, then go for other referential videos. Okay. See, the problem is nowadays the reference data is too much. People are having 16 GB data for just CCNA notes. 16 GB notes they are having for CCNA. No point. That doesn't work. Where it will work, whatever notes I'm giving, you're going to learn it, you understand the concept, and then go check the referential data, whatever, then read it accordingly, do the practicals. That will help you. Okay. All right. Now we'll do class B. So 172.16.0.0/21. Okay. Okay. Here, new subnet mask is equal to 21, right? So 1, 2, 3, 4, 5, 6, 7, 8 dot 1, 2, 3, 4, 5, 6, 7, 8 dot 16 is there, 17, 18, 19, 20, 21, 22, 23, 24 dot 0. Okay. How I'm going to find the subnet? Same 2 to the power of 2. That is 1, 2, 3, 4, 5. So 2 to the power of 5 is what? 32. Then we're going to find the block size. What is the block size means? 2 to the power of 2 to the power of 3. 3 bits are remaining there in the octet. So 2 to the power of 3 is 8. 8. Okay, now valid host. How much? 6. What is the point of CIDR 25, 26, 27, 28, 29? In 29, what you are getting? Valid host. 6. Because 3 octet is left. 3 octet is left on the other side, that is 30, 31, 32. So 2 to the power of 3 is 8 block size, and minus 2, you will get the valid host as 6. So if you are getting the same in host, class B, then what is the point? You have to add everything here. So range will increase in your class B. Okay, the range will increase in your class B. That is 2 to the power of 8, 9, 10, 11 minus 2. Understood? Before that, you just write down this. So 2 to the power of 0 is 1. 2 to the power of 1 is 2. Then 4, 8, 32, 64, 256, 512, 1024, 2048, 4096, 8192, 16384. Okay, 32768, and then 65536. At least 16 you should be knowing it. Okay, quickly write down these things.
After the 2,000, is it correct?
5.2.
512, 521 I written, 512, 102. Write down this quickly somewhere near your subnetting notes. Initially you're writing, right? First problem you solved. Before that you can write down these things. Written? Okay. So here 2 to the power of 11 is 2048. 2048 minus 2 is equal to 2046. So in your class B, this range, you will get 32 subnets. 32 network you can get. And out of this 32 network, you get each network we will get 2046 IPs. Okay, so if I'm having an organization and I need 2000 PCs, then I will go with CIDR 21. Okay, how I'm going to break the range means, see, it will start from 0. Correct. That means 172.16.0.0. Okay, next range will be 8.0. Next range 16.0, 24.0, 32.0. Likewise, it will go. Okay, and then in the range, you will get 172.16.7.255. Here, 15.255. Here, 23.255. Here, 31.255. Here, 39.255. So this is the range. In this range, from 0 to 0 to 7.255, you will get 2048 IPs. So these IPs are called network ID. And then here you have broadcast ID. Okay. So this is the range. And each range you are getting how many IPs? 2048 IPs. But the valid host, the range between these network ID and broadcast ID is 2046. Okay. The same thing, just the octet change from third octet because of CIDR 21. 21 means changes occurs on third octet between 16 to 24. Okay. The same concept, just the octet changes. If you can understand class C clearly, this is easy.
Sir, for block size, why we have taken that HS3 and valid host it is 11? No,
See,
that
block
host
size is only this block. Only you have to take the octet for the block size. Only octet you're going to take. Whereas your
Sir,
host only you have to take completely.
oh, for host we have to take fully
Correct.
valid host. For block
Correct.
size, only the third.
Yes. Okay.
Hmm.
Write it down.
And is there any formula like you told for class C we divide it? No.
No, there is no formula. Only 2 to the power of network, 2 to the power of host. Only two formulas you have.
Hala,
Hmm.
there we divided that host by block size. No.
Host by block size.
Yes, just before problems. No, for finding network ID and broadcast ID.
Okay. Hold on. I'll come one by one. Don't
Yes.
go to the straight away to the CCIE. Finish CCNA first.
Not sir.
Hmm.
Before question we did divide it. No, like
Yeah.
that.
This problem it is not there. I will show you. Wait.
Okay.
But Devidas, I already taught you this subnetting, right?
Sir, actually there is a long gap. No.
Long gap? No, I don't think so. Less than a
Yes,
month.
yes. Yes. But
Hmm.
we, like you told, if
Hmm.
we don't study regularly, it will forget.
Then study
Mm.
regularly.
Okay.
Hmm. Yes. Turned off everything is valid host. Written? Okay. See here 16.0.0 is what? Your network ID. Wait. Here 16.0.0 that is 172.16.0.0 CIDR 255.255.21 means what? 248. Correct. 1 17, 18, 19, 20 and 21. 248.0. See now I'll give this IP, it will not take. Correct, because that is the network ID. But if I give, so here you have 16.0.0. In between there are 1.0, 2.0, 3.0. Correct. So I will simply give 5.0. See, it will take it as a valid IP. So that's why you start from 0. 0 can be a valid IP. And also your 255. For example, here I will give 4.255, where it can be a valid IP again. So 0 and 255 also can be a valid IP. In class C, it can be a valid IP. But in class B, it can be a valid IP. Okay, that's why you start from 0. Clear? Now I'll show you another problem. I'll say 19. So 19 means how many bits on? 17, 18, 19. So these two bits are 0, 0. Correct? And subnet will be 2 to the power of 3. So 8. Block size is 2 to the power of 5. 32. Valid host will be 2 to the power of 13. 8, 9, 10, 11, 12, 13. That is 8192 minus 2. So 8190 valid IPs you will get from one network. So how will be the range? So 0.0 and then 32.0, 64.0 and then 96.0. Likewise, it will go till 8. Correct here? 31.255, 63.255, 95.255, and then here likewise it will go. Okay, so this will become network ID, and here it is broadcast ID. So here what will be the subnet mask? 255.255.224.0. Okay, any doubt on this? No doubt. Okay, write it down quickly. Another problem. Done. Written, everyone?
Yes, sir.
Okay. Likewise, if there is a problem like this, then if it's 21, then how many bits are on? So 8, 16, 17, 18, 19, 20, 21, 22, 23, 24. Correct? And then rest are zeros. So subnet will be 2 to the power of 5. So 2 to the power of 5 is 32. So block size is 8 and valid host is 8, 9, 10, 11. 2 to the power of 11 is 2048 minus 2, 2046. So how I'm going to find this network belongs to which network and broadcast ID? The same concept, whatever we did in your class C. So 153, you divide it by, what is the block size? 8. So 1 time 8, 7, 3, 9 times 72, 1. So minus 1. So 172.16.152.0 will be the network ID. What is the block size? 8. So you're going to add it by 7. 159. So 172.16.159.255 will be the broadcast ID of this network. Okay. And in between, you will get 2046 IPs starting from 152.1 to 159.254. This is first, last valid IP. Okay. The same method. Whatever you did in your class C, same thing you're going to do, but instead of taking the 100, you're going to take 153 because of the octet change. Here octet change is on third octet, not fourth octet. So that's why you're taking 153. Okay, write down this problem also. That's it. One more problem and we can finish subnetting.
Earlier problems we could not do like this because it was 0, right?
Yes.
That host person was 0.
Yes, correct. Is it in JavaScript also they are telecasting, right? No, only Sony lives. Sony Live only. By end of, if India choose to bat, by end of the day we will know. End of the day we'll know the result of the test. Better. Weekend is good this time. Saturday, Sunday. Written, guys? What's theory written? Yesterday you were asking about this advanced. Did you speak to Nikun sir? No. First is finish CCNA, finish routing switching, then think about advanced automation. Because then you will have a little bit idea about it. Okay. Because sometimes people like security concepts, some people like only enterprise concepts. Okay. So if you finish routing and switching, you will know, okay, I like this routing and switching, I'll go with this. Some people will be like, no, firewalls are more interesting, I'll go with firewalls. What course have you enrolled for?
CCNA.
CCI security only. Then you'll be learning both enterprise and this also. So accordingly, you can choose. Firewall is totally different when you compare with your CCNA and NP routing and switching. So there, every policies you will create, how to filter a traffic, how to allow a traffic, what is inside network, outside network, what is DMZ. So multiple things you will learn in your firewall. Okay, it is actually very interesting. And practicals of firewall is also, it is little more complicated when you compare with your CCNA and all, but makes, it's little different. You will allow a traffic, you will block a traffic. Interesting it is. Especially, for example, FTD. FTD firewall, it's a next generation firewall of your Cisco. So what you're going to do, if it's a ASA firewall, you go to that particular firewall and you will configure just like a router. Okay. Whereas FTD, what you're going to do, there will be 5, 6 firewalls, for examples. Okay. And there is a, your FTD works on your GUI access, that is graphical user interface. So there is something called FMC manager. Okay, you will integrate all the 5, 6 FTD firewall into one FMC manager, and from that one FMC manager, you will be able to access all the 6 FTD firewalls. Okay, you don't have to go to each and every firewall every time. No, in that one web page itself, that is graphical user interface, you can configure all the IPs, policies, access lists, everything. So how you will integrate a firewall, how to give a privilege to it. Okay, so what they'll do is in real time, the manager will have the access of all the firewalls. Okay, so there will be L1 employee, L2 employee. He will give a priority level of less, so that what a L1, L1 and L2 employee, they can log into FMC manager, but they can't configure it. Simply they will monitor the firewall. What is the traffic coming, going? Is there any change of IPs? Is there any, other outside network trying to reach in? So they will monitor, and if any changes, they will push the log to senior person, and they will do the configurations. So these things from one tab only, they will be able to manage everything. Okay, these things you will learn in your CCIE. Very interesting it is. All right. How many of you are for CCIE? 1, 2, 3, 4, 5. Only CCNA U. Only CCNA. Combo. Okay, leave combo. Okay. One last problem we'll see. Then we'll go to concepts. So today after class, we'll go to lab. I'll show you the routers and switches. And by next week, we'll configure it. Today, just basically, we'll see what is a router, switch or not. Okay. So 172.16.0.0. Okay. It means here changes occurs on which octet? 4th octet. 8. So 24, 25, 26. Like this. So 255.255.255.192. So here block size is what? 2 to the power of how many bits are remaining? 6. So 2 to the power 6 is 64. Valid host will be 62. Correct? So here only 1, 2, 3, 4, 5, 6 are there. So 62. But subnet, it will change here. What is the range of this IP? Class B. 172 means class B. So subnet you have to add from here to here. From third octet you are going to start. So that it will become 8, 9, 10. 2 to the power of 10. That is 1024. So 1024 subnets you will get from this address, and each address will hold 64 IPs, but valid hosts are 62. Okay, one change will happen if it's the changes occurs on fourth octet. Okay, but it is class B, so that's why we are going to calculate it from the third octet. Okay, write down this quickly, and we'll go to next concepts. What is the subnet mask? 26. So you find the subnet mask first initially. Okay. Then block size, whatever zeros are there, block size. -2, you will get the valid host. Why I'm going to calculate from here subnet, but not here? Because it is class B. 172 means what? Class B. So that's why I'm starting from the third octet. What is the default subnet mask value of class B? What is the default subnet mask? CIDR 16. That is still here. That is the default subnet mask of class B. So that's why the changes occurs from here. That's why I'm calculating it from here. 2 to the power of 10. Okay. If I'm going to calculate it from here, then that is class C, right? Here it is class B. That's why I'm starting it from here. Okay. Done, written? Okay. Your major part is over. From now, everything is about concepts. You will learn a lot of theories and practicals from now on.
Sir, for interview, they will they ask to do configuration on this simulation tool?
What configuration? No, they will not give configuration. What they will do is they will give you a topology and they will ask questions accordingly. If I'm going to send the packet from here, the packet is not going. What might be the reason? Or if I'm sending a packet from this side to that side, okay, and it got successful. Explain how it is being successful. Okay,
Oh,
it is not successful. Why it is not successful? It is not successful. How to troubleshoot that so that the packet will be successful. So these kind of scenario questions they will give you.
practical based
Correct.
application.
That is called scenario based questions, and you will get
Yeah.
those questions. Okay.
We will get any training for that scenario based?
Scenario, that's what you're getting now.
Okay, this is training.
Yes. That's why you enroll for CCNA. I'm going to explain you the scenario based questions. I'm going to explain you theoretical based questions, practical questions, every questions. Okay. So each and every topic I'll teach, and that time itself I'll tell you this kind of questions you can expect. And this is how you should answer. Okay. And they may ask like this also, they may ask like that also. Every topic I'm explaining. Okay. So today I took an interview. In that interview, I asked, what is subnetting? What is subnet mask? What is the use of block size? Okay. And I asked him, what is the subnet mask value of CIDR 30? And he was not able to calculate it. Sorry, CIDR of 29 I asked. And that person was not able to tell the value. Okay, you tell me what should I add? He said 128 plus 64 plus 32 plus 16 plus 8. I said, okay, that is fine. I don't want exact value. I just want to know if that person understood or not. So he said 255.255.255 dot 128 plus 64 plus 32 plus 16 plus 8. That much is enough. I don't want to know the addition. He added correctly. He did not say plus 4 or he did not stop at 16. He added the 8. That means 5 bits he added. That much knowledge you should have. That's all they will expect from interview. Okay. And mostly they will not ask you what is the 10th valid IP of 12th subnet. Those kind of questions are very rare. They will not ask you very deeply. Okay. So now we are going to learn FLSM and VLSM. FLSM means fixed length subnet masking. That is FLSM, fixed length subnet masking. Here, your subnet mask will always be the same. So in my organization, there are IT department, sales, and HR. So in IT, I need 120 PCs, HR 60, sales 28. But fixed length means what? Every department I'm giving same subnet mask, 25, 25, 25. If it's 25, how many IPs I'll get? 128 IPs. Correct. In that 126 valid IPs I'll get. Correct. So here also 126 valid IPs, here also 126 valid IPs. So it is going to fulfill the IT department. Correct. 120. So only 6 IPs are wasted. But come to HR department, 60 IPs are there. How many IPs are getting wasted? 66 IPs are getting wasted. Likewise, in your sales, 98 IPs are going to get wasted. Okay, so what is the disadvantage in FLSM means? Wastage of IPs. Okay, but what is the advantage we have? Scalability. That means, see, in future, if I'm trying to increase the HR department, I'm going to add plus 30 PCs. Then I don't have to purchase another network and do the routing. Simply, I will add it from this remaining IPs. So I have 66 IPs, so easily I can accommodate another 30. If I'm increase sales of 50, then easily I can increase it from use this IPs. So scalability is there. That is the advantage we have in FLSM. Okay. And if you cut down and if you come to VLSM, if you come to VLSM, here we are going to change the IPs according to our use. We're going to change the subnet mask according to our need. Here 120 PCs are required, so I'm going with /28. So I'll get 126 IP. Wastage is 6. Here 60 IP need. I'm going with 26. So 62 valid IPs I will get. 60 I used. So only 2 will be wasted. Likewise, 28 IP. Going with CIDR 27. 30 IPs I will get. 28 I used. 2 only. Here, what is the advantage here? No wastage of IPs. Okay. And disadvantages? No scalability. Vice versa. Correct. So here, if I'm going to increase 10 PCs here, then this is not sufficient. So I have to buy another network. I have to do the routing. I have to do it on the other routers also. So this problem we have. So no scalability, but no advantages, no wastage of IPs. That is VLSM. VLSM means what? Variable length. The name itself, you can see, we are defining the subnet mask according to our need. That is variable. FLSM means fixed length. It is fixed. You can't change it. Every department will have the same subnet mask. Okay. Now we are going to learn the most important thing. That is what? Your OSI model. Okay. So I already told you where this networking started. That is in your 1945, correct? So they came up with this TCP IP model. Okay. So what is this TCP IP means? It is a routed protocol. Routed protocol. So what is there in this? It is like a set of documents. We have set of documents. Under the set of documents, we have set of protocols. And under these protocols, we have certain rules. According to the rules, the set of protocols, set of documents, set of router protocol, your packet is going to be behave like that. Okay, so inside this TCP IP, we are having protocols, multiple protocols or documents already pre-built in. Okay, if I say do this, then according to that protocol, according to the rules, according to the documents, it is going to behave like that. Okay, if I'm saying send a mail to this source to that source, from this mail to that mail, then that is a rule. So it will look, okay, it is a mail. So I have to use SMTP protocol, that is simple mail transfer protocol, and it will send the mail. If I have to open a web page, if I have to access a web page, then it will use HTTPS. Correct. If I have to use telnet, then it will use telnet. If I have to ping, then it will use ICMP protocol. Likewise, each and every rules are set in inbuilt in that TCP/IP. So which year it came? 1945. Okay, at that time we did not have the OSI layer. We had only TCP/IP. It is called routed protocol. So what is a routed protocol? Write down an important point. It carries data from one end to another end. It carries data from one end to another end. Written? And nearby you can make a small table and write down for routing protocol. Routing protocol. So here you can write it doesn't carry data. It doesn't, routing protocol doesn't carry data. Instead, it creates path for routed protocol. Instead, it creates path for routed protocol. Instead, it creates path for routed protocol. For example, underneath write example. You can write down rep version, EIGRP, OSPF. These are examples. What is this EIGRP, OSPF and all? We'll learn in routing next week. Okay. And then for routed protocol, example is TCP/IP. TCP/IP. Written. So what is routed protocol? It is going to carry the data. Okay. See, always in routing, I will again tell you, but you should know the clear difference between routed protocol, routing protocol, what is routing, what is router, what is route. Okay. All this should be very clear. These are very basics. Then only you will be able to understand the topics. Okay. So here, as of now, what is routed protocol means? It is a set of documents, set of protocols, and under the protocols, we are having rules. So when I say send the packet from source to destination, it is going to behave according to the documents and rules, which are already built in. Okay, what is the use of router protocol means? It is going to carry the data. Okay, and where this routed protocol works? In your transport layer. It works on your transport layer. In first class itself, I shown you this OSI layer. So that's why we call transport layer as the heart of OSI. Now you understood? Because it is the reason you're sending the data from one end to another end. Okay? All right. So in this TCP/IP, we have been using, there is no standardization. No standardization. That means, see, initially, if I have a Dell monitor, okay, I have to go with Dell keyboard, Dell mouse. If I have IBM monitor, I have to go with IBM keyboard and IBM mouse. Everything is same vendor. There was no standardization. So in your 1984, your ISO has developed this OSI. OSI. What is OSI? Open System Interconnection. So they came up with 1984, they came up with this. Here they have made it standardization. That means a Dell laptop can use IBM keyboard, HP mouse, Lenovo speaker, anything for that matter. Okay, and your OSI model is called the reference model. because your OSI model will not carry the data. Your TCP IP carries the data. Then why we are using this OSI model? For the troubleshooting purpose. For what purpose you are using? For troubleshooting purpose. After that, in 2000, they came up with TCP IP updated. They came up with TCP IP updated. So the same TCP IP, they have added more protocols, they made it more secure, they've enhanced it, they made it more better, and now we are using TCP IP updated. But why we are learning OSI? To get the complete understanding of the layers. Okay, now I'll show you the layer, difference layer. Now you will understand why we are using OSI. See here. What is OSI layer? So it's Open System Interconnection, developed by ISO, and it was developed in the year 1984. Okay. And then here you can see this is your OSI layer. This is TCP IP original, that is came in 1945. This is 2000. See, the problem in TCP IP original is there was no complete transparency. That means your network layer is called internet layer, and both data link and physical layer are called as link layer. Okay. But whereas in your OSI, they made it physical, data link, network, transport, session, presentation, and application. So every layer they divide it into 7 layers. In your TCP IP updater also, your application layer is called as application layer only. But inside the application layer itself, you will have presentation layer, session layer, and also application layer. So that is not easy for your troubleshooting purpose and to understand the packets. So that's why we call it as OSI as reference model. And we are learning the OSI model, but your data is carried through TCP IP. Okay, so here also you can see, though it is updated, but still it is in one layer only. But this 3 layers, they have changed it. Here you can see internet layer was changed to network, link layer was changed to data link and physical. Okay, so we are sending data through this one, and we are learning and troubleshooting through OSI. Okay, you want to write down this or no? Okay, if you want, you can go through the I'll share the PPTs anyway. Are you getting the PPTs every day, right?
Yes.
So today I will upload this PPT. Okay. Today I'll finish class by 3:30 and we'll go to lab. Okay. So this is your OSI layer. Here you can see software layers, that is application, presentation, and session layer, and these are called software layers. Likewise, you see network, data link, and physical, they are called hardware layers. And this is called heart of OSI because your TCP IP works on your transport layer. Okay. So now we are going to learn each and every layer in detail. Okay. How a data travels. So a sender is sending a data. That means he is sending high text. He is sending a hi in your WhatsApp or your email or whatever. Okay. So it will go from application layer first, presentation, session, transport, network, data link, and physical layer. And they are connected through physical medium link. Physical link, they are connected. Okay. So it will go to again physical layer, data link layer, network, transport, session, presentation, and application. So it will go from application to physical, again physical to application. Okay. So how the data is traveling in each and every layer, what is happening exactly at backend, that we are going to learn. Because see, simply we're going to email. I'm typing the email. Okay, this the details. Okay, and we are just sending it email, and we immediately the mail goes. But what happens inside it, backend, what happens? That is your technically that you have to explain. Okay, that is the reason we are doing CCNA. Understood? So application layer is your user interface layer. Here you can see application layer is called the user interface layer. Okay, so all your protocols, application layer protocols works on your application layer. That is FTP. That means what? File transfer protocol. It is used to transfer files from source to destination. And then HTTPS, that is for web browsing. If you go to Google and if you type something, then that is what? HTTPS. What is the difference between HTTP and HTTPS, guys? HTTPS is more secure. HTTPS in plain text. So nowadays we are using only HTTPS. Okay. And then we have SMTP, Simple Mail Transfer Protocol. That means I don't know why people are keep on asking this. So, okay. See here, I got a mail. That is what? Okay, we are delighted to extend a warm welcome to you. This is a gentle reminder that CCNA class will commence on Monday, 16th June, 2 to 4 p.m. That is your class. So they have informed me saying this. But do you think this is the original mail? No. So this is the mail I've received. This is the message ID and created by time from this my mail. Everything is there. So this is the actual mail. This is the backend mail. Can I read this? No, I can't read this. But how I'm getting this email? Because of this SMTP. So this protocol is helps me to send the mail from source to destination. And this SMT protocol works in your application layer. So in your application layer, you are sending the message so that it will hit the SMTP protocol. So in your TCP/IP, we are having this SMTP protocol. If they is using mail, then use this protocol. This document you have to use. Likewise, we are using it. Okay, now is it in readable format? No. How it is changing from system readable format to user readable format? What are the encryptions going on? What is the authentication there? What is the authorization there? How is the IP it is knowing? Okay, how is the MAC address it is knowing? Everything comes in your OSI layer. So the 7 layer is very important, each and every layer. Okay, because if a problem happens in one layer, then still the packet will not be sent to the destination. So whatever it is matching the 7 layer, the same thing should be matched from the other 7 layer also. Okay, so if I'm encrypting in this side, it should decrypt in this side. Okay, if I'm giving an authentication on this side, the same authentication should be matched on the other side. If I'm giving source IP and destination IP, so here this destination IP will become source IP here, and this source IP will become destination IP on the other side. Okay, likewise, everything should match. Then only the packet goes from source to destination securely. Okay, we want it to be secure. So if I'm sending a data, for example, I'm sending on data. What is your name? Sandeep. So I'm sending SANDEEP. Okay, Sandeep. What if someone change the name as SANDEP instead of double E? They're changing it to one E. That is not the actual packet. So how I will identify that they have changed it? I have to know, right? If some hacker is going to manipulate the data and send it to me, how will I know? That you will come to know under your OSI layer. In which layer that I can identify that. Okay, so these kind of things you will learn in your OSI layer. Okay. Okay, now let's learn this application layer. So application layer, all your protocols, application layer protocols works on your application layer. It is called your user interface layer. Okay, and this is the 7th layer for different protocol service.
This meeting is being recorded.
It's already being recorded. Don't worry, I will share the video. Yeah, Mohammed Shanid. Mohammed Shanid. Is it your first class? Who's Mohammed Shanid?
No, sir. I'm attending online today.
Okay, okay. Okay, Mohammed Shanid, if you want, you can record, but no point. Anyway, I'm going to send the recording in your drive access. You can download their complete class. All right. So, what is the use of this application layer? Every protocols works there, and it's called the user interface layer. What SMTP is for email service? HTTPS is for browsing, web browsing. FTP is for file transfer protocol. So we have multiple protocols there. What is this telnet and SSH? Any idea?
Using access.
Access. What access?
Secure access
What virtual access? What secure access?
for accessing remotely securely. It
Correct. That
can
means
use SSH.
remote access. We are getting the remote access. So in my third floor, there is lab. I'm sitting here. So there is three ways of getting connection to a server. One is physically. I can just take the terminal server. Now I'll show you in the lab. I can take the server. I can connect it to my laptop, and I'll be able to do the practicals. I mean, do the configurations. That is one way. Other way, those all terminal servers are connected to a Wi-Fi. I connected to that particular Wi-Fi. I don't have to connect physically. Using this telnet and SSH, I'll be able to access those internet. As long as I'm connected to that Wi-Fi and the rack is also connected to that Wi-Fi. That is another way. I'll give all the authentication and I'll be able to get the access. Other third way, again through telnet and SSH, that is remotely. So we have a port number and a link. Okay, so I'm going to give that link and port number. I will give the username password and I will be able to get the remote access of that rack anywhere from the world. Okay, so three ways we can do. I will show you all three ways. Okay. Question? No. So that is why we have telnet and SSH. So in practicals, I will clearly show you why we are not using telnet anymore. Telnet we are not using. Why? Because it is in plain text and it is unsecure. So we have a separate class for telnet and SSH. In that we will learn all the theories, practicals of telnet, theory of SSH, and the practicals of SSH. So once we finish telnet and SSH, then we can go to lab. Okay. All right. Now we'll learn for presentation layer. Presentation layer. Okay. So this layer defines the format of data. Okay. That is user readable format to system readable format. Okay. So here translations happen. Compression. Encryption. Decryption. What is encryption, guys?
So not plain text into ciphertext.
Convert
Plain text
Hmm.
into ciphertext.
ciphertext. Okay. Same answer. What about others? Unreadable format. Very good. So that is encryption. Converting the readable format to unreadable format. That is plain text to ciphertext or scrambled text in simple. Okay. So your presentation layer defines the format of data. Okay. So what does your system understands?
Then
Binary. That is zeros and ones. Correct. So it will translate this to letter. Okay. So this side we have system A. This side we have system B. Correct. So data will come like this and go like this. Correct. So here it will be in zeros and ones in system readable format. when it goes to the destination, in this side of presentation layer, it will retranslate it to letter so that he can read the actual data. See, initially I saw the mail, correct? Was it able to understand the original mail? No.
Government developer submission.
So, were you be able to read it? No, right? So who is responsible so that I was able to read that, okay, we are delighted to tell you that we have a batch from 2 to 4 because of your presentation layer. Your presentation layer is changing the data from readable to unreadable format and unreadable to readable format. So that is your translation. It defines the format of data. Okay, and what is this encryption decryption? That is, it is going to change the readable data to unreadable format. See? Here I'm going to send the details. So in this presentation layer, it will encrypt the data because he is sending the hi message. This presentation layer will encrypt it, and while the packet will go from here to here, this presentation layer will decrypt it. Okay, and then we have compression. So here 100 MB per second can be sent from this source to destination. Okay, so there is a packet. There is a packet of 100 MB. Okay, so in how many seconds it will go here? In 1 second. In 1 second it will go there. That is fine. So what is this compression is? So I'm going to make a packet like this. So inside this packet, I will keep this 100 MB packet. Okay, my actual packet is this only. That is 100 MB. But this packet is 20 MB per second. 20 MB packet. So what I can do? So I can send 5 20 MB packets. Correct. So how much data will be went? 500 MB can be sent in 1 second. So it will compress the packet inside a packet and it will send the data from source to destination. So all the compression, that is your this JPG, GIF, we are sending in WhatsApp and all, right? So all these compressions happens in your presentation layer. Okay, your SSL TLS protocols that is used for your encrypted for encryption. We are using this. This you will completely learn in your VPN and all. Okay, so that's why your presentation layer is important because your translation happens there, your compression happens there, encryption happens there, decryption there happens there. So if you want to explain presentation layer, so you can simply say, so it defines the format of data, that is what? User readable to system readable format or system readable to user readable format. And translation happens there. That means zeros to ones are converted to letters and letters are converted to zeros and ones. And then encryption, decryption, it will change the format of data from readable to unreadable, unreadable to readable. That is encryption, decryption. Compression means it is going to compress the packet inside a packet and send the data from source to destination. Okay, so this is a presentation layer. Okay, so first is going to send the hi message. It is going to hit the protocol SMTP, then come to presentation layer. Their encryption will happen. It will compress the packet. It will change it to system readable format, not user readable format. It will be in system readable format. Okay, when it goes to other side, he will change it to user readable format. Okay, so this is your presentation layer. Now come to PPT. See, translation, compression, encryption, decryption. Okay, so here you can see this is translation, that is letters are changed to binary. Okay, and encryption, you can't see the packet, so that is encryption. And then this is what? Compression. 5 MB packet is sent as 2 MB file. Okay, that we are doing it in your presentation layer. All right, now we'll see. session layer. So what does your session layer do? It establishes session, establishes, manages, and terminates the terminates the session. Okay. That means, see, you're going to say, for example, you're downloading a movie. Okay. In Google, you're downloading a movie. So once you click the download tab, it will go to another web page. Correct. So that means what? It establishes a new session there. Okay. And then you can see suddenly your internet went off. But your file will not completely go, it will be paused. Correct. But again, you can go and make it play so that the resume so that the download will be happening. So that means what? It is maintaining the session there until the file is downloaded. It will maintain the session. That is maintaining. So during this maintaining session, you can see the internet speed is high. Correct. Normally your internet is slow while the file is downloaded. You can see the internet speed is high. Correct. Once the file is downloaded, you can see the internet speed will go again down. Why? Because that session is terminated. So your termination is very important. As long as establishment and maintaining, termination is also very important. What if you don't terminate a session? Then your internet speed will be keep on high so that you can't access the other applications very fast. Correct. So that's why maintaining, establishing, and terminating is also very important. For example, you're using ATM. First, initially it will open a session. Correct. Once you put the ATM card, you can see a new session is open. And while you give your withdrawal, all the details, you can see it will be maintaining. The session will be keep on maintaining it. Once you received your cash and if you pull out your ATM card, then you can clearly see the session is terminated. What if the session is not terminated? Then still a person can access your withdrawal tab, or they can go check the balance if they know your password, even without ATM card. So that's why termination is also very important. All this establishment, managing, and termination happens in your session layer. And also very two important thing, that is your authentication and authorization. What is authentication? If you're using a net banking, initially what they'll ask you? Username, password. So username and password is your authentication. We are setting a limit. So who can access it? Who should access it? That is your authentication. So I'm making sure only Dinesh can use it, or Srihari can use it, or Mohammed can use it. So according to their authentication, they will be handling the authentication. That is fine. What is authorization? So what you're supposed to do inside that? Okay. For example, take same net banking. Okay. You're going to give your username, password. You're logged into your net banking. Okay. There, what you can do? You can send money. You can view your account statement. You can check your balance. You can apply for credit card. You can apply for debit card. All these things are fine. So for example, if you have put your PIN number of your ATM 3 times wrong, then what will happen? Your card will be blocked. Can you unblock your card in your net banking? No. What you have to do? You have to go to your bank branch. There they will check all your physical documents, your Aadhaar card, whatever, and then they will do it. They will unblock the card. So you are not authorized to unblock your credit card from your net banking. So they are setting a limit for you. So this much you are authorized to do, not everything. But your bank manager can authorize to unblock your card. Okay, this is your authorization. To understanding purpose, I said this network, like net banking and all. When you cut down, if you come to networking, what will happen in real time? So they will give you the access of router. But you can't go and configure it. It will take you 2 to 3 years for you to configure a router. Okay, as a fresher, they will not allow you to touch the router. That means what they will do? They will give the access of router. But what they will do? They will set the privilege level. So privilege level is 0 to 15. By default, privilege level is 1. So they will set the privilege level as 5 for you. So with the privilege level of 5, what you can do, you can simply see what are going through in the network. What is the routing table? Okay, what are the networks there? What are the IPs there configured? Okay, am I able to ping to this destination? Am I able to trace route this destination? These kind of things you will be able to do it. So how they are setting you the privilege? By the privilege level. They're going to cut down the privilege level and then they're going to give you the access. Manager will have the privilege level of 15 so that he can handle complete router, complete configuration. You will be able to do it, but you are not doing it. So you are authorized to do only certain level. So that authorization takes place on your session layer. Okay. And also it provides simplex, half duplex and full duplex. Simplex means one-way communication, half duplex, one at a time. Full duplex, two at a time. So these things also defined by your session layer. Okay. So establishing, managing and termination of session, authentication, authorization, and also this simplex half duplex communication is handled by your session layer. Okay. So as of now, we have seen application layer, presentation layer, session layer. Now I'll teach you transport layer. Okay. And then we'll go to lab. Rest of the 3 layers we'll see tomorrow. Okay. That is Monday. Tomorrow I have off. Please don't come. See. You can come to NH, but lab is open. You can, if you want, you can use the lab. So here you have application, presentation, session layer, correct? Until session layer, the data is in the form of data only. Here also it is called data. Here also it is called data. Here also it is called data. Whereas in your transport layer, it will become segment. Data is called segment in your transport layer. Okay. Guys, return this. You recording and you will see, right? Okay. But don't forget to write these things, okay? I usually give time to write. Today I'm going. Your notes are very important. Notes are very important because when you're going to prepare, at that time it's very much required. Now it feels like I understood everything. At end of CCNA, you will forget OSI layer again. At that time, this notes helps you. Okay. Okay. So transport layer is used for end-to-end communication. Correct. And then it provides service to application layer. And it establish communication between software and hardware layer. Okay. See, here segmentation will happen. That means there is a packet called data. Okay. The packet is like this. So how this packet will be changed? It will be changed to DATA like this. D A T A. This data packet is segmented to, instead of data, it has been segmented to DATA. And it is going to be sent from this source to this destination. Okay. What if this packet is coming like this? Instead of data, I got the packet, original packet. I mean segment, but it is a what? Tada, not data. The order of the packet is wrong. Correct? How I'm going to change it to from Tada to data? Simple. So in your segment, you will have a sequence number. Sequence number, you will have a port number, and you will have a checksum value. Okay, these three things are there. So what is the sequence number? It will have a number 1, 2, 3, and 4. So here, what is the here it is 3, 2, 1, 4. So what it will do, it will get the segment here and it will rearrange accordingly. It will rearrange like this. How it is rearranging? Because of your sequence number. Okay, and every time you will have a source port and destination port. For example, if I'm using a telnet, then that will use a 23 port number. If I'm using SSH, 22 port number it will use. If I'm using HTTPS, 443. So likewise, according to each and every protocol, that port number is designed. Okay, so source port will be random port number and destination port will be according to the protocol we are using. So that protocol port number will be there in the port number there. And then what is this checksum value? Very important, and every time they are asking in interviews. Checksum. What is the use of checksum? So here I got the data packet here. What if I got the packet as like this? Is it correct? Why? Instead of capital A, it is in small a, that is in lowercase. Correct? While I'm reading it as data only. But is it the right packet? No. Is it the right segment? No. Someone have manipulated the packet in between, segment in between. They've changed it to uppercase to lowercase. Okay. What if it's a password? You can't open the password, right? So you will have a checksum value. A random value will be there. So when I get this packet, the checksum value also will be the same here. 1, 2, 3, 4, 2, 1, 5, 1, 2, and here it will be 3, 2, 2, 3, 2, 2. But what is the actual checksum value? 3, 2, 1. Here it is 3, 2, 2. By this value, I will come to know, okay, this segment is not trustable. This is not the actual segment which I received from the source. So he will re-ask. He will ask to retransmit it. Okay. He will ask, the destination person will ask the source to retransmit the packet because I can't trust this packet. The integrity is not there. What is integrity? That means the same thing has gone from source to destination, but it is not here. How I will come to know? Through this checksum value. Understood? And also your port number works on your transport layer. What is the range of port number? 0 to 65535, in which 0 to 1023 are known as well-known port numbers. Well-known port numbers are reserved. Okay. 10242 6553 are dynamic. Dynamic port numbers. Okay. Your port numbers works on your transport layer. Because in the packet you have in the segment you have this port number, right? And also sequence number and checksum value. So what is this checksum value? This is called your error control. It is used for error control. How I'm going to why I'm saying it is error control? Because if the value is changed, I'll come to know, okay, this is error. This packet is not the right packet. Okay. If a segment is missing, I can ask him to retransmit the segment again, but he will send the segment through the checksum value. I'll come to know, okay, this is the missing and I got the correct one. Okay. Now come to your PPT. So in your transport layer, segmentation, that is data to DA, TA. Error control means what? That is what you have seen in the checksum. This flow control will come. This connection and connectionless transmission means what? Your TCP and UDP. So your transport layer works on your two protocol. Who is this keep on recording and discarding it? Please don't do it, no? So TCP and UDP. You have two protocols. This TCP UDP we'll see on Monday. freshly we'll see, because there are handshakes, headers. I will explain you completely what is the difference, where we are using TCP, where we are using UDP. That separately we'll see. And then the rest of 3 layers: network, data link, and physical. Once that is done, your OSI is over. Okay. So that is your TCP UDP, connection and connectionless transmission. Here you have flow control. So segmentation, here you can see data that has been segmented into small parts. Here you have sequence number, port number, and checksum value. See, here there is a file missing. So it will ask to retransmit it, and you get it data unit 2 as checksum. Okay, if it's corrupted, you will come to know by the value of the checksum value. Okay. And then here connectionless, for connection oriented, we are using TCP, and connectionless, we are using UDP. What is this? We'll learn in Monday's class. Here we have one thing, that is flow control. So flow control means, see, this system can send 100 Mbps data, but this can receive only 10 MB. So he is sending 50 Mbps data in the speed. So he will say, I can't handle this much. You reduce the speed and send me. Okay. So that is flow control. Here you can see 110, but the data is sent by 5 Mbps second. So he can handle up to 10, right? So he will say increase the speed. And here you can see 10 Mbps, you can maintain this 10 Mbps. Likewise, according to the data being sent, the speed of the destination, they will change the flow control. So this flow control, segmentation, error control, connectionless, connection oriented, all your port numbers, end-to-end communication, all works on your transport layer. Okay, so here you have application layer. I'm going to send a hi message in email, so it will go to SMTP protocol. It will come to presentation layer. It will translate it to the system readable format. Then it will encrypt it. It will compress it, and then it will send it to session layer. Here authentication and authorization will be done there. Is it a simplex or half duplex communication? And then it will check for the session establishments. Okay. Then it will go to transport layer. There you will have TCP or UDP. According to that protocol, it will choose it. It will segment the data packet. Okay. And then after that, it will check the error control, flow control, and then it will send it to network layer. Okay. So tomorrow's your task is write down what is encapsulation. What is encapsulation? Written. What is protocol data unit? What is protocol data unit? And then protocol data unit segment. What is fragmentation? Fragmentation. Written. Yeah, these 3 things I need to know. Okay. Monday I will ask you. Okay, online guys, any doubt on today's class?
No, sir.
Clear?
No, sir.
All right. So I don't want to take completely on one day. So we have learned 4 layers today. We have a rest of 3 layers, TCP, UDP, that will keep it for Monday. Okay. I don't want to push everything on same day
Sir,
also.
after watching that recording, you will ask any doubt. Please.
After watching recording, what?
If you have any doubt, I will ask.
You can text me in WhatsApp. Otherwise, if I'm free, I will reply. Otherwise, I will answer on Monday.
Yes, that is what I mean.
Okay. Because every time I get messages at night 11, 12, 1.
Oh,
Yeah. So if it's any emergency, you can text me in WhatsApp.
okay.
If I'm there, 100% reply to that message. If not, Monday, you can ask me.
Okay, for another thing, for CCNA, it is fine if we work from this packet tracer itself, right?
Yeah, complete every
Cisco
CCNA practicals you can do in your Cisco packet tracer itself. I will
Okay,
upload the Cisco packet tracer. on Monday or Tuesday, I will upload it. Once your
Okay.
practical starts, I will upload it in your drive. You can install it.
For CCNP only, we need to come there, right? For lab.
No. CCNP also you can do from there only. We have different softwares like GNS, EV, and G. So you can install that and you can use it from home also.
Same software as there.
Correct.
Okay, Tamal. Okay.
Okay. All right. Anything else, guys? Anyone else? All good? Okay. I will end the meeting here because I'm taking the students to lab to just show what is a router, switch, and all. Again, next week I will take you to the lab once more. So at that time, I will let you know in before so that you can come there and you can see how I'm going to take the access of the routers. Okay. All right. Thank you, guys. You can leave the meeting.